Hi dear students, today we have come with a new video of class 11. In the previous video we have discussed about the first part of motion in straight line, and there we have learned a new mathematical tools, that is differentiation. So today only we have to discuss about the numericals that may come in exam from differentiation and exactly what is the use of differentiation. In the previous class we have discussed little, today we will discuss it little elaborately. So coming about the questions. Okay, so I'm giving a heading, questions from differentiation. So first we'll go for some easy question, just like if it is given to you that y equals to x square sine x, y equals to x square sine x, then how we can able to find out dy by dx. Okay, see, we have already learned that if I want to find d dx of uv, where u is a function of x and v it is also a function of x, then our equation is equation is du by dx into v plus u into dv by dx. Okay, so here also you see this x square and sine x, both are function of x and both are separate. So we can assume this is u and this is v. So if I want to find out dy by dx, so first I have to differentiate u and v will be as it is. So d dx of x square, right, and sine x, it will be as usual because it is v as per this equation, plus here x square will be as usual and we will differentiate sine x with respect to x. Okay, so if I differentiate it, x square d dx of x square, we learn a law that d dx of x to the power n, that law is n x to the power n minus 1. Okay, n x to the power n minus 1. So here it should be, here n will be 2, so 2 x to the power 2 minus 1 into sine x plus x square, and d dx of sine x we know it is cos x, and our answer will be 2x sine x plus x square cos x. It's a very easy thing. Okay, so that is our result, that is dy by dx. Sometime this dy by dx, that is differentiation y with respect to x, that can be denoted as y dash. So y dash means dy by dx. Clear? Okay. Sometime it is told that you have to differentiate double. So our next target is to learn double differentiation. Double differentiation means we have differentiate once y with respect to x, then we have to differentiate again, means differentiation of differentiation. It is written as d dx of dy by dx. That is called double differentiation. So if I multiply here, or if you do here, it will be written as d2y by dx2. Okay, in some places it is known as d square y by dx square. I am little differ with this terminology. Why we will not say it is d square? See here, d2 represent, we have to differentiate double, whom? No, y. With respect to whom? With respect to dx twice. So dx is differentiating twice. Once here, another one is here. So it is not a square. We are differentiating two times. If I want to differentiate again, then it will be d3y by dx3. So that is double differentiation. Differentiation of differentiation. So let's see if I want to do differentiation of differentiation with the above function. So it will be written as d dx of 2x sin x plus x square cos x, because this one is your dy by dx. Okay, now I will do directly. So here for the first function, this is u and this is v. This is u and this is v. So if you do it directly, so 2, it is a constant. So first we have to differentiate u, next x. Okay, we have to differentiate x. So we can write d dx of x into sin x as it is, plus 2x, it will be same. Now the next one, the differentiation will be sin x. So the first function, it is over. Now we have to come to second function, x square cos x. That is the second function. So here also, this one we have to take as u, this one we have to take as v. So here also you see the product, uv, it's a product. So we will differentiate this one as like the previous formula. Then we'll go for this and we'll treat it as a separate function. We will treat it as a separate function. So here if you see, so first d dx of x square into cos x as v plus x square into d dx of cos x. Okay, so now if I put the value dx upon dx, so dx upon dx means what? 1. And if you don't understand, sir, how it is coming 1, so you will go by this formula, d dx of x to the power n equals to n x to the power n minus 1. So what is n here? 1. So 1 will come. Okay, so if I differentiate x, that means 1 x to the power 1 minus 1, 1, it will come forward as like n x to the power n minus 1. So 1 into x to the power 0 means 1. So dx upon dx equals to 1. So it will be 2 sin x plus 2x into differentiation of sin x, it is cos x, right? d dx of x square, we have just done it. It is 2x cos x plus x square, it will as it is, and d dx of cos x, it is minus sin x. So here we have to directly write minus x square sin x. So it is double differentiation, that is known as d2y by dx2, and we denote it by y double dash. So it is y single dash means dy by dx, y double dash means d2y by dx2. Just like this, you can do y triple dash, so it will be d3y by dx3. So that's why the differentiation, it will go on. Okay, and what is the use of this differentiation? That we'll discuss little later. So I think this question is clear. Okay, now we'll discuss by another question. Just like I think in the previous class also I have told it, but again maybe you have not noticed, so that's why I will do it again. Just like if a function is given to us, that is sin x by x. If a function is given to you, that is sin x by x. Okay, so how you will differentiate it? Now it is told that you have to find out y dash. Y dash means dy by dx, right? Now in this case, we will go by the formula, that is d dx of u by v, where u and v both are function of x. Remember one thing, u and v are not constant. These are function of x. See, u, we are taking u is sine x, and you see it's a function of x. V, it is x, and it is also a function of x. Okay, so what is the formula of it? The formula is v square v into du by dx minus u into dv by dx. That is our formula. V square, it is a denominator, and a numerator v into du by dx minus u into dv by dx. So let's do it. Here v is x, so directly we have to write x square. Okay, and that should be constant. So x into d dx of sine x minus, now sine x will be constant, that is your u, and d dx of x. So here you see x square, x sine x is differentiation cos x minus sine x, and d dx of x, it is 1. So your answer will be x cos x minus sine x by x square. That is y dot. Now if it is told you to find y double dot or y double dash, how you have to do it? To find y double dash, let's split it. X cos x by x square minus sine x by x square. Now this is used as u by v formula, this is used as u by v formula, and now do it. That will be your homework. That is y double dash of this one. Okay, let's see whether you can able to do it or not. Okay, now we'll go for another function. Okay, then we'll discuss that what is the need of this differentiation in our physics. In the previous class I have already told, so I'll explain it again. If you are having any doubt, I think the doubt should be cleared. Now one function that is not discussed in the previous class, but this type of function also sometime asked, that is sine x square. If it is given sine x square and it is told to you that you have to find dy by dx, how you have to do it? If it is given to you y equals to sine x, then you might be telling that it is very easy and we have done it earlier, that dy by dx is equals to d dx of sine x, and we have to write directly cos x. No problem. I'm telling yes, there is a problem. Here we have to miss one thing. What is, we are writing d dx of sine x is cos x into, along with it, as it is x, it is dx by dx. And as dx by dx equals to 1, we are write directly cos x. But when it is coming x square, then our target or our idea is changed. Y dash, that is dy by dx, is equals to sine x square, means it will be cos x square into d dx of x square. D dx of x square. So d dx of x square means we all know it is 2x. So the answer will be 2x cos x square. 2x cos x square. Actually, instead of sine x square, if it is y equals to sine, actually forget about sine. We are dealing much thing about sine. Cos 5x. If it is cos 5x, then it will be differentiation y dash, it will be minus sine 5x into d dx of 5x. So d dx of 5x means we have already done it. If you do it separately, that d dx of 5x means 5 is a constant term, it will come out dx by dx. So it is 5. So this 5 will come here, minus of 5 sine 5x. Okay. So like this way we have to do our differentiation. Okay, so differentiation you will learn more in your mathematics portion, but the portion is needed for our physics, that only I have discussed here. Now we'll discuss what type of question has come and what we just want to find out through differentiation. And from this question I will suggest you have to find y double dash of this one and y double dash of this one. This two you have to do, that is your homework. So 3 homework I have already given. Now I am coming to what is the need of differentiation in physics. So in the previous class only we have discussed that by differentiation we are finding slope. Okay, so what we have got or what we will get from differentiation, so we can say that by differentiation we get slope of a graph, right? So in class 9 you remember we have learned the graphical representation of motion. So we have done a distance time graph. So it is distance, it is time. We have done velocity time graph. Okay, this type of graph we have done, and whatever the graph, it may be looking like this, it may be looking like this, whatever, we are not bothered about that. So as we are finding the slope, so we in the previous class also I have told the slope of displacement time graph, by that is the tan theta, what we get, now we get velocity. So we know that slope of displacement time graph gives us velocity. So if I'm having a displacement equation, if I differentiate it, I'm getting velocity. So differentiating displacement, we can write differentiating displacement, we get velocity. Now let's see one example, then it will be very easier for us to finding out the displacement from to find the velocity from the displacement. Assume a equation is given to you just like the displacement x is equals to 18t plus 5t square in meter. It is given to you. The displacement of a body is represented to you that x equals to 18t plus 5t square. Here you see displacement, it is a function of time. That is obvious because that's why we can able to draw the graph. Displacement is definitely a function of time. And now it is asked to you that you have to find the velocity of the body. So now how you have to find the velocity? Simple thing, we have to find the slope. So slope means here slope theta equals to differentiation of x with respect to time. Differentiation of x with respect to time. Now you might be asking, sir, just now we have discussed y is something sine x or something like that, and we are finding dy by dx. Now suddenly how t has come? How t has come? So y and sine x, whenever we have told it, so along this we are taking y axis, along this we are taking x axis. But now we have changed. Along y we have taken displacement, which is represented by x. Along x we have taken time. Okay, so it is represented by t. So slope theta should be dx by dt. Okay, now the differentiation with respect to time, we are taking d dx, but here we have to take d dt. Why? Because we are taking along x-axis, but now along x-axis it is time. 18t plus 5t square. Now differentiate it. 18 is a constant, it will come outside. dt of dt plus 5, it will come outside. dt of t square. So dt upon dt, it will be cancelled out. So it is 18. 5t square. So if it is d dx of x square equals to 2x, so d dt of t square, it will be 2t plus 5 into 2t, right? So it will be 18 plus 10t. That is our velocity. 18 plus 10t, that is our velocity, right? So if the displacement is given to us, we can able to find the velocity. Okay, now from here only one question has asked that tell when the velocity will be zero. Tell when the velocity is zero. So here I'm just erasing the first portion because it is not needed for us. That thing I have written earlier also. We have find out dx by dt, that is equals to 18 plus 10t. What is it? It is your velocity v. It is your velocity v. Now if it is told to you that find the time when uh, so forget about find the time, that we will do little later because it will come negative here. So from here, if it is told to find acceleration, if it is told to find acceleration, how we have to find acceleration from it? Now we'll go for our another idea. If a velocity time graph is given to you, so we know finding the slope of velocity time graph, we get acceleration. So we'll get velocity. Okay, so we differentiate once the displacement, we'll get velocity. If I want to find acceleration, so acceleration is what? Slope of velocity time graph. We have already known it. And slope of velocity time graph means how we can able to find it? Now differentiating velocity. So if I differentiate the velocity, I can able to get the acceleration. So let's differentiate it. Okay, so velocity v equals to come 18 plus 10t as per our previous question. So differentiation will be dv by dt now, because differentiation of velocity with respect to time, because time is along in x-axis. So it is very easy, d dt of 18 plus 10t. So you see d dt of 18, what is it? It's a constant. Okay, there is no x or there is no t term, and we are differentiating with respect to t. Differentiating means we are finding by the change of time how much velocity is changed. But you see it is a constant, there is no t term here. That means this will go on to 0, because we have learned the differentiation of constant will be 0 plus d dt of 10t. So 10, it is a constant, it will come outside, and dtt of dt. So the answer will be 10, right? The answer is 10, and you see here no t term is there. Here no t term. So no t term means this is a constant acceleration. It doesn't depend on time. It doesn't depend on time. So it is a constant acceleration. Okay. If I rewinding our ideas, we are differentiating displacement, we'll get velocity. We differentiating velocity, we'll get acceleration. But rather, we can say in another way, if displacement is given to you, you differentiate it with respect to time, you will get velocity. And when you differentiate velocity, you will get acceleration. In another way, we can say if you differentiate displacement doubly, means d2 and dt2 of displacement, that will give you acceleration. Why I am writing it? dv by dt, that can be represented by, see, d dt of v. This v can be written as d dt of dx by dt, and that means it is d2x by dt2. Okay, so if I differentiate once the displacement, I'll get velocity. If I differentiate twice the displacement, I'll get acceleration. Okay, so this type of questions are coming in exam, right? We will discuss more question. Let's see what type of question has come in exam. See, I have given a question to you and read it. What is written? The position of a particle along y-axis is y equals to 2a t cube minus 6b t square plus 9c t. It is told find the velocity of the particle when the acceleration of the body is 0. See how we can able to do it. What is given? Now we have given to you the displacement, that is 2a t cube minus 6b t square plus 9c t. It is told to us that we have to find out the velocity when the acceleration will be 0. So velocity equals to what? The slope. That means differentiation of the displacement, that is dy by dt. So let's see, d dt of 2a t cube minus 6b t square plus 9ct. By the way, one thing is not mentioned, that is a, b, c is constant, are constant. Okay, so there is no problem with that. So here 2a, it is constant, so 2a will come outside, d dt of t cube minus of 6b will come outside, d dt of t square plus 9c will come outside, d dt of t. So first t cube, again the equation is same, that is n t to the power n minus 1. So what is n here? 3. So it should be 3 t to the power 3 minus 1, right? It is our equation, minus 6b into t square means it is 2t, t to the power 2 minus 1, 2 minus 1 means it is 1 definitely, plus 9c dt by dt, so it is 1. Let's multiply it. So 6a t square minus 12bt, that is our velocity that we have got, plus 9c as usual it is there. Now it is asked find the velocity of the particle when acceleration of the body is 0. So to make the acceleration 0, we need to find the acceleration. Here velocity is given. So let's find the acceleration dv by dt, because this is the acceleration, differentiation of velocity with respect to time, because that will give the slope. So 6a, it is the constant, it will come outside, d dt of t square minus 12b d dt of t, and 9c, see it's a constant. So if I have done d dt of 9c, that means it will goes to 0. Okay, so here you see 6a into 2t minus 12b into 1 dt of dt. So here it is coming 12at minus 12b. 12at minus 12b, that is our acceleration. That is our acceleration. Now what is told in the question? In the question it is told your acceleration should be 0, then what will be the velocity? So acceleration is already given, 12at minus 12b. It is told acceleration is 0. So if a equals to 0, so from this equation 12at minus 12b, that should also be 0. Acceleration is 0, it's already told. And here 12at is equals to 12b. From here you can able to find the time. So time equals to b by a. 12 will be cancelled out. So time t equals to b by a when my acceleration is 0. Now if I put the value of b by a to the velocity, I'll get the velocity when the acceleration is 0. So as t equals to b by a, I have to put on the velocity. So velocity v equals to how much? 6a t square minus 12 bt plus 9c. So here t means, you see, it is changed. It is the variable quantity, time. But here when acceleration is 0, we will get the time. Time equals to b by a. So what will be the velocity at that time? Put the value. 6a t square means b by a whole square minus 12b into b by a plus 9c as usual. So here a square and a, so it is 6b square by a minus 12b square by a, okay, plus 9c. That is our velocity when acceleration is 0. So it is little hard numerical, not hard. Okay, so here we have just told that what will be the acceleration, what will be the velocity when the acceleration is 0. But rather, if I am talking that what type of question has generally come in the exam, so that is very easy. Just like if it is given, okay, I am erasing this thing. If you have not written, just pause the video here and see it. Okay, so assume one question is given to you, just like the displacement x is given to you, that is t cube minus 6t square plus t minus 4, and it is asked what will be the velocity of the body when when the time equals to 2 seconds. So find v at time t equals to 2 seconds. So what we have to do? Very easy thing. These are the easy numerical that generally come. So x equals to t cube minus 6t square plus t minus 4. Let's differentiate it, dx by dt, because this is equals to v. So it will be t cube means I can directly write it is 3t square minus 12t plus 1 and 4, it's a constant, it will be 0. So the v is given, v we already got. Now we have to find v at t equals to 2 seconds. So put the value t 3 equals t, in case of t we have to write 2 square minus 12 into 2 plus 1. So 3 into 4, so it is 12 minus 24 plus it's 1. So 13 minus 24, so 13 minus 24 means it is minus 11 meter per second. That is our velocity. So this type of questions may come in exam. So if from here it is asked you have to find the acceleration, so you will differentiate again. Okay, you will differentiate again. That means here v you have find out, that is 3t square minus 12t plus 1. Okay, so dv by dt, that is equals to your acceleration. So it will be 6t minus 12 and this will be 0. If it is told find acceleration at time t equals to 2 seconds, so 6 into 2 minus 12, so it is 12 minus 12, it is 0. So our acceleration in 2 seconds, it will be 0. So this type of questions have come in exam. Okay. Now I'll just introduce one interesting thing. If you are having any interest in joint, neat, then only the next part is important for you. If you are not interested on this, then you can leave the video from here. Okay. If you are only focusing the board exam, so the next part is not needed. If you're interested in competitive exam, then you will see the next part. So I have already told it is a part which is not very much important for board paper, but it is important for the competitive portion, that is maxima and minima. We can say that it is an integral part of differentiation. Okay, it's the integral part of differentiation, and you will learn more on maxima and minima in your maths. But here in physics also it is needed very little. Okay, mainly in competitive exam some question has come from it. So here we just want to understand what is maxima and minima. So assume I am having two axes, y and x, and one quantity y which is a function of x. If we represent it, it seems to be looking like this. Okay, so that is the curve that shows the representation of y which is a function of x. See, one interesting thing, if I am taking a point here and here, assume this point I am telling it's a and this is b. So here if I have drawn a perpendicular, assume this point is x1. So at x1 point the value of y is maximum. We can tell it y1. And at b point, if I have drawn a perpendicular, that point along x, it should be x2. Here the point is minimum and we'll get a minimum value of y here. So in one function we'll get one maximum value and one minimum value. Okay, so if a function is given to us, how do we understand that which one will be maximum and which one will be minimum? So first we have to draw a tangent on A, okay, and tangent on B. So these two lines I have drawn, these are tangent along A and tangent on B. Both the tangents, if I write here, both the tangent at maxima and minima are parallel to x-axis. You see, both the tangent, whatever we have shown here, both the tangent are parallel to x-axis. What it represents, what it tells? It tells that the slope at maxima and minima is 0. Why? Because we know slope means the angle made by the tangent at any point of the curve with x-axis. So as we have seen, the tangent are parallel to x-axis, so angle with x-axis is 0. So if the angle is 0, so we can say the slope will be 0. So as the slope is 0, dy by dx, that will also be 0. So if a function y is given to us, so in both maxima and minima, the differentiation will be 0. Okay, the differentiation will be 0. Now you might be asking, sir, if the differentiation is 0 for both maxima and minima, then how do we understand that which point is maxima and which point is minima? So for that reason, we'll just take another idea or another example. You see, if I've taken this point, assume this point is C, and I've taken another point here, assume this point is D. So C point is just like the previous point of maxima, and D point is just after point of maxima. If I have drawn a tangent at C, so if I have drawn a tangent, we will get a slope here. This is theta 1, and we can say this slope is positive slope. So we can say theta 1 is equals to positive slope. Now why it is positive slope? We know that always the slope, that angle is measured from x-axis. If the angle is in anti-clockwise direction, that is positive. And if I have drawn a slope along D, okay, it should be gone by this way. I'm sorry a little bit. So it will go a little later. So here assume it is theta 2, but here the slope theta 2 is negative. Okay, so what we have seen, that before the maxima the slope is positive, and after maxima slope is negative. So we can conclude, or we can say that at maxima the dy by dx, or you can say the slope, it will be decreased. So we can mention that after maxima the slope goes to negative just after maximum. Now the very interesting part, and please pay attention here. Now assume if I differentiate again, that means if the differentiation of the slope at maxima should be negative. That means slope is dy by dx. If I differentiate again, so if there is maxima, means differentiate again means we again to find the change of the slope, or of the change of y with respect to x with respect to another x. Okay, means we have to doubly differentiate it. That means d2y by dx2 at maxima, that it should be negative, because we have seen after maxima the slope gone to negative. So the differentiation of the slope at maxima, that should be negative. So if I get a function, So first we have to do the differentiation dy by dx, and we will make it 0, and we have to find the point where we have to find dy by dx is 0. Now whether it is maxima or minima, for that reason we have to differentiate again, and if after differentiation we will get that it is coming negative, so at that point we will get maximum. I know you are not able to understand what I have told, so let's see an example. Assume y equals to 2t into 3 minus t. This is a function given to you, so we can easily multiply and say it is 6t minus 2t square. So let's differentiate it first. Dy by dx. So if I differentiate, it will come 6 minus 4t. Okay, 6 minus 4t. Oh, I'm sorry. We are differentiating with respect to t. Okay, so as the function is t here. 6 minus 4t. So then what we have to do? So to find maxima or minima, dy by dt should be 0. Now you might be asking, sir, you have told x here, why it is t? Because here along x-axis we have taken time. Okay, what is x-axis? We have taken time, that's why it is dy by dt. So obviously 6 minus 4t equals to 0, and here t equals to 1.5 second. Now the confusion has come that t equals to 1.5 second, whether we will get maxima or minima. So as y equals to 2t minus 3, we will get it that it is basically the velocity. So whether the velocity is maxima or minima, how do we understand? So for that reason we have to differentiate again d2y by dt2. So if I have done d2y by dt2, it will get for 6 it is 0, and for here it is minus 4. So d2y by dt2, it is negative. So negative means at that point we will get maxima. At that point we will get maxima. Okay, this is the way where we can able to find maxima. So if it is asked that what will be the maximum displacement, then you have to put this 1.5 second into here. If you put it, you will get what is the maximum displacement by the body. What is the maximum displacement by the body? Clear? Okay. Now we'll come for minima. What we have seen for minima? If I have seen the diagram, that at B point we'll get minima, right? So now I have to take one point here, assume it is E, and one point here, assume it is F. Okay. So now again we have to draw a slope. One slope is coming here, just like exactly with D. So it is theta 2. I am just erasing this portion. I think you have understood that. Okay. So now we are discussing for minima. So for maxima, so in which point there will be maxima? To find the maxima, we have to do first dy by dx, that should be 0, and d2y by dx2 should be less than equals to 0, that means negative. And then we will get maxima at that point. Now I am coming to minima, where we have to find the minima. So for minima, the minima point is B. I am taking one point F. Assume here the angle is theta 3, that is the slope, and if I have drawn a slope from E, it is theta 4. You see theta 3. Okay, so slope, how we have to do it? We have drawn a tangent, and the tangent is touching on x-axis. What angle is made? That is the slope. So theta 3, it is negative slope, and theta 4, it is positive slope. So at maxima, you see at minima that before minima, that is negative slope, and after minima, we can mention that after minima slope is positive. So now if I differentiate again, dx of dy by dx, that should be positive, because we have seen the after minima the slope changed to positive. So dy by dx of dy by dx means change of slope at b. So change of slope at b should be positive, because after minima the slope want to be positive, right? So where the minima we will get, so to find the minima or to find the minima point, what we have to do, the first we have to find dy by dx, that will go to 0, and if d2y by dx2 is greater than 0, that means positive, then at that point we will get minima. If d2y by dx2 is negative, we will get maxima at that point. If d2y by dx2 is positive at that point means by making dy by dx, what value of x we have got? By getting dy by dx, what value of x we have got, based on that we will get. So let's see an example, then it will be easier for you to understand. Okay, we just want to see an example. See, assume one example I have given, that y equals to x minus 3 into x plus 1. Y equals to x minus 3 into x plus 1. So just multiply it, x square plus x minus 3x plus, minus 3. Okay, now x square minus x minus 3, that is the value of y, minus 2x, I'm sorry. Now if I differentiate dy by dx, it will be 2x minus 2, and for 3 it is 0, because differentiation for a constant quantity it will be 0. Now make dy by dx equals to 0. dy by dx equals to 0. So to find maxima or minima, up to this step it is same. Make dy by dx is 0. So dy by dx is 0 means 2x minus 2 equals to 0. So x equals to 1. Clear? Now find d2y by dx2. That means d dx of 2x minus 2. Find it. So if we find, you will get 2, because here it is 0, so it is 2, which is greater than 0. So at x equals to 1, we will get what? Minima. If it is coming, assume if I have given a minus sign here, and then it will come minus 2x, and there we will get minus 2, and that will be maxima. So it is not like that in a function always we will get maxima and minima together. Sometime in a function we will get maxima, sometime in a function we will get minima. Okay, the rule is, first you have to make dy by dx equals to 0, and then do d2y by dx2. If d2y by dx2 is less than 0, then you will get maxima. If d2y by dx2 greater than 0, then you will get minima. Okay, so this is the extra thing I just want to tell you. So based on maxima minima, some questions are there. First I will suggest you will go through the books questions you are having, and then if I get time, then I will do more question through differentiation and maxima minima. Thank you.